So aldehyde, ketone, carboxylic acids, acidic nature, order, trick. Okay, first line CF3 NO2 CnFCl Bri pH phenyl. So CF3 netizen, fluorine, chlorine, bromine, iodine. Okay, so acid nature greater for fluorine. Understood? So CF3 netizen, fluorine, chlorine, bromine, iodine, pH. Why fluorine greater? That is electronegativity more, that's why acidity also more. So netizen, fluorine, chlorine, bromine, iodine, phenyl. First one CF3. Clear? So next this one is based on pKa values. So pKa low means acid is strong. So now first we know CF3 COOH, next CCl3, fluorine, chlorine, so CCl3, next CHCl2, instead of one chlorine hydrogen, so CHCl2. Understood? Next, so next NO2, so NO2, so fluorine, chlorine, so that one hydrogen replaced by, sorry, one chlorine replaced by hydrogen, this is, and next one is NO2, next CN, next fluorine. Okay, next fluorine, next chlorine, bromine, and next important formic acid. Formic acid is the least. Up to this one it is the least. If they are giving this order, this is the least. So then next one means it is continuing. So chlorine, because here chlorine, here distance is more, so that's why less acidic character. So Cl, next C6H5, right? Phenyl, C6H5. So C6H5 CH2. Comparatively these two, what? This is greater because this is distance from COOH. So distance should be tightly, it should be there. Next CH3COOH, acetic acid. Acetic acid is least than benzoic acid. Okay, benzoic acid, this one, what? C6H5 CH2COOH. Okay, next one is last CH3 CH2 COH. Completely memory based. With some tricks and tips we can easily understood this one. Thank you.